We'll proceed in innovative approach in calculus, and we will begin a new topic, that is partial differentiation along a vector. Partial differentiation along a vector. That is something that is always brain cracking. Brain cracking is understandable, I believe so. So, brain would crack in a way that partial derivative, partial derivative along a particular vector, partial derivative along a particular vector. Okay, what is partial derivative along a particular vector? Consider a 3D. Okay, I have 3D. Okay, I really have 3D. Okay, so I have 3D. In that sense, what is directional derivative along a axis? Now, hoop, hoop, hoop. Okay, okay, so this is x-axis, this is y-axis, this is xy plane, this is fxy, function over x and y, this is z. Okay, if this is xy plane, and on xy plane I take many points. In xy plane I take 100 points. Now for each point is called x comma y. Now I feed x comma y to a Python function, and it does some internal computation and returns a number. Then I give another x and y to the Python function. It does some computation and returns a number. 100 times I call the Python function with different x and y. So if it is xy plane, this is x-axis, this is y-axis. In that scenario, if this is xy plane, this is x-axis, y-axis. In that scenario, I pick 100 points on xy plane. These 100 points, I pass it to Python function. X comma y is the parameter and returns a number. Consider whatever is returning at that x comma y, that is the vertical point. At this x comma y, this is the vertical point. At this x comma y, this is the vertical point. At this x comma y, this is the vertical point. If I connect all these 100 points, it will make like this. Okay, so consider this is a sphere. Okay, is it not a sphere? Okay, I have bigger one. This is sphere. Okay, this is really a big sphere, not fully a sphere, but it looks like a sphere. Okay, so if this is xy plane, and then if it is very heavy. So if this is, now this is xy plane, this is x-axis, this is y-axis. Now I take 100 points here. If I take 100 points, every point I pass it to a Python function, and that Python function compute over x and y and returns a number. That number x and y returns a number. That number is the height. So if this is the x comma y, then this is the height. If this is x comma y, then this is the height. If this is x comma y, then this much is the height. If this is x comma y, this is the height, like that. Now if I connect all the points, then it forms a it forms a sphere. Okay, then anyone would ask, what magic you did? What magic you did that you connected all the points and it became a sphere? What magic you did? I did not do any magic. I applied a formula that is x square plus y square plus z square equal to a square. Yeah, that is the formula of a sphere. Z equal to a square root of a square minus x square minus y square. Now, whatever x and y you are giving, a square is the radius of the sphere. A square is constant, minus x and y, whatever is provided, a square root, that is the z. At each x and y point, I have different z value because of this formula. And if I connect, it's become a sphere. Okay, if that is the scenario. If I try paraboloid, that is z equal to x square plus y square, will it be paraboloid? Certainly it will be paraboloid. It can be a cone. It can be whatever the formula someone applies. This is three-dimensional. This is how things are drawn in three-dimensional way. If that is the case, if it is drawn in three-dimensional case, then okay, I was thinking, very heavy. Okay, this is also very, very heavy. Okay, so now consider this is x-axis, this is x-axis, this is y-axis, this is z-axis, that is the height. Now, this is the sphere that is kept and this is xy plane. Now, if I cut it like this, if I cut it like this, exactly like this, then it will make a circle. If I cut, where are you cutting? I am cutting in xz plane. If I cut like this, where are you cutting? I am cutting in yz plane. XZ plane, YZ plane. If you are cutting in XZ plane, then it will become a circle. If you are cutting in YZ plane, then it becomes again a circle. Circle, circle. If this is the circle, then what are the variables? If I am cutting it in XZ plane, this is X axis, this is Z axis, XZ plane. This is Y axis, this is Z axis, YZ plane. If I cut it into XZ plane, then it will make a circle like this. This is X axis and this is Z axis. In that case, if I vary in X, then there is a variation in Z, it is seen. What is equation of x and z? This is a circle. Certainly, equation of x and z would be x square plus z square equal to a square. That is the radius of the circle. That is the radius of the sphere. I cut it in xz when the sphere is centered at the origin. If that is the case, then what about dz by dx? Z equal to square root of a square minus x square. Z equal to square root of a square minus x square. What is dz by dx? First of all, what is dz by dx? The dz by dx, okay, if this is x-axis and this is z-axis, dz by dx means at any moment, if I take x, what is z? If I move one unit in x-axis, how much unit change I see in z? Okay, dz by dx means if I move one unit in x, how many unit z is moving? Dz by dx at x equal to x1. X equal to x1. Then at x equal to x1, what is z? At x equal to x1 plus 1, 1 means it can be anything. It is not necessary it is centimeter or millimeter. 1 unit. If I move 1 unit, then how much z is changing? This z and this z, subtract it, divide by 1, you made the change along the x-axis. That is dz by dx at x equal to x1. Or x equal to x1 and then move delta. So x1 and this is x1 plus delta. At x1 what is z and x1 plus delta what is z? Subtract it, this z variation happened because x moved delta x. Subtract the z, new z and old z divide by delta x. Means delta, because of delta x unit change, z change this much. If I divide it, I get how much z is changing per unit change. Dz by dx. Dz by dx is tangential. Dz by dx is tangential. So dz by dx is also called slope. So if I make a line that is z equal to dz by dx into x, that line will be like this. That will be tangent at every moment. dz by dx, dz by dy, dz by dx, dz by dy. What you are talking about? I'm talking about variation in z with respect to x-axis, dz by dx. Variation in z with respect to y-axis, dz by dy. If that is the case, then x-axis means, are you talking about I vector? Yes, dz by dx or dz by di vector, dz by dj vector. If that is the case, then you're trying to do something like this. Someone would ask that this is x-axis and this is y-axis. Then dz by dx, dz by di, dz by dj, dz by in xz plane, z is varying how much in along I vector. In yz plane, z is varying how much along j vector. What about how much z is varying along any vector u? How much z is varying along any vector u? That is the question. This is x-axis, this is y-axis, then this is I vector, this is j vector. What about any vector u? How much z is varying? What are you talking about? Any vector u means what? In any direction. Okay, so I am going to take big one. It's very heavy. Okay, this is a sphere. This is a sphere. If this is a sphere, this is x-axis, this is y-axis, this is z-axis. In that sense, this is centered at the origin. Then at the middle, this is x-axis, at the middle, this is y-axis, and this is z-axis. The center of this sphere, it is not a sphere, but I'm considering this is a sphere. Center of this sphere, center of this sphere is the origin. In that sense, what is dz by dx? If I cut it, means dz by dx at any point is a tangent in xz plane. dz by dy, that is a tangent in yz plane. If that is the case, tangent in xz plane, yz plane, what about there is this is x-axis, this is y-axis, there is another axis called u vector. This is I vector, j vector, u vector. If this is u vector in this direction, this is u vector, then I cut this in xzu plane. I can cut this in xz plane. I can cut this in yz plane. Now I can cut this. This is xz plane. This is yz plane. I can cut this in any uz plane. U along u vector. This is u vector. This is x vector. This is y vector. This is u vector. Okay. So I can cut this in x in zu plane, zx plane, zy plane, zu plane. If I cut it in zu plane, so this is xz plane, this is yz plane, this is uz plane, little bit tilted, xz plane, yz plane, uz plane or little bit tilted, uz plane. This is u vector, x vector, y vector, I vector, u vector, little bit tilt shifted, and then j vector. Now, if I cut it in zu plane, this is what will come. In that sense, if this is the u vector, then what is dz by du? That is the question. What is dz by du? Directional derivative along a vector u. dz by dx is directional derivative of z along a vector I. dz by dy is directional derivative of a vector, along j vector. J is a unit vector. U may not be unit vector. We will get the unit vector. directional derivative of z along any vector u, dz by du. Cut the sphere in uz plane. If this is u along the z axis, cut it. If you cut, it will make a circle if it is a sphere. Then if this is u, then if I move along u, then if this is point, consider this is point is u or u1, then at u1 there is a z value, height is, there is some z value. At u1 plus delta u1, and this is u1 plus delta u1, and I move distance. This distance is delta u. Delta u is numeric. So this is u1 and this is u1 plus delta u. At u1, height is z, height is z. At u1 plus delta u, height is z2. How much z moved? Because I moved delta u. That's, if I subtract that by delta u, that is dz by du. Dz by du means along u direction, if I take u1 point and see z value. So it is like, if it is like this, then at any point u1, this is z at the z. At any point u1 plus delta u, this is new z. If I subtract this z, how much change happened in z divided by delta u, that is dz by du. This is what we are trying to find. Partial derivative of z along vector u, dz by du. Dz by du is nothing but, what is z? What is z? Okay, dz by du means change in delta z. Delta z by delta u. How much delta change at u1 position? At what point? So partial derivative happens at what point you are trying to calculate the partial at point u1. Any point u1, what is the partial derivative? What is the partial derivative of z of I mean what is, I'm sorry, what is directional derivative of z along the u direction at point u1? At point u1, dz by du at u equal to u1. Simple. Directional derivative of z along u is nothing but, at point u1 is nothing but dz by du at u equal to u1. We did it, right? Dz by dx at x equal to x1. Similarly, dz by du at dz by du at u equal to u1. If that is true, then what is z value at u1? What is z value at u1 plus delta u by delta u, or z value at u1 plus delta u minus z value at u1 divided by delta u, or the top is delta z and bottom is delta u, delta z by delta u, dz by du, when du tends to 0. So in algebra we call it, at that point in the algebraic calculus, the primitive calculus, there is no delta delta. So at point u1, what is z? That is one question. At point u1, what is change in z? I can see. What is dz? One is z and what is dz? What is z? Oh, anyway, so z is function over x and y. This is what we have seen. Z, the height is function over x and y. We took example of Python. So dz by du is nothing but f. F. Consider the u point, the u1 point. We are talking about u1 point. At u1 point, u1 point is x1, y1. After all, it will be described in Cartesian coordinate x1, y1. So f1, f1, x, f1, x, x1, f1, I'm sorry, function f, z is fxy. So f x1 plus delta x1 plus delta u, its component along x-axis, comma y1 plus delta u, its component along y direction. Mind it, minus fxy at minus fx1 comma y1 by delta u. Z at u1 plus delta u minus z at u1 divided by delta u, that is dz by du. But whatever we are talking, it is available in the book. If this is difficult, we will have another proof, that is our proof. Now z at u1 plus delta u is nothing but f z equal to fxy. So z at u1 is f x1 comma y1. So it is f x1 plus delta u component along x-axis plus comma y1 plus delta u component along y-axis minus f x1 comma y1 divided by delta u. What we are trying to do with this equation? We are trying to find delta z. Simple, right? If this is x-axis, this is xz plane, this is yz plane, this is uz plane. If this is uz plane, at point u1, what is z? And at point u1 plus delta u, what is z? Change in z by delta u. Delta z by delta u. Change in z by change in u. Delta z by delta u. How much delta z we are seeing? Okay, what is formula of z in 3D? What is formula of z in 3D? Many times we have proved it. Z is nothing but dz by dx. What is z at any point x1, comma y1? If I take xy plane, this is x-axis, this is y-axis. At any point x1, comma y1, what is z? That is function over x1 and y1. Okay, z can at that moment z can also be described as z equal to dz by dx, change that is seen in z with respect to x at x equal to x1 into x plus dz by dy, change in that z that is seen at y equal to y1 into y. Or if I want in algebra means z in term of dz by dz, then z equal to dz by dx. dz by dx would come, dz by dx would come as algebra again. So z equal to dz by dx into x plus dz by dy into y. If that is the case, we have seen many times. Okay, simple case I can take over. If this is x-axis, this is this is y-axis. Y-axis is a simple line. It is tilted at angle theta line. Okay, at any moment, what is y? At any moment, what is y? Y is nothing but whatever dy by dx is, whatever the slope is multiplied by x. Slope multiplied by x. But in this kind of sense, we cannot say that what is y, then slope what we see, because slope is different at every moment. Slope is different at every moment. It's not constant like line. So what is y at this point? At this point, what is the slope? At that point, what is the slope? Into x. That is the line, that's the equation of this line. Or equation of line is nothing but y only. So y equal to dy by dx calculated at x equal to x1 into x, whatever x we are taking. Okay, that moment. That is the y at that moment. If it is a circle, what is the equation of circle? X square plus y square equal to a square. Y equal to square root of a square minus x square. Dy by dx is minus x by square root of a square minus x square. When x equal to x1, calculate the value. That is dy by dx at x equal to x1. What is y at x equal to x1? Whatever dy by dx into x, that is the y every moment. What is y at x equal to x1? Now you can substitute in the square root of a square minus x square, x equal to x1, you will get the y. Here also you will get the y, or you get the equation of the tangent line, whatever it is. Now if it is 1D, 2D, if it is 3D, similarly z equal to dz by dx means if this is xz plane and this is yz plane, then at any moment what is z in xz plane? So at any point x equal to x1, how much is the z? dz by dx into x. At any point y equal to y1, what is the z? dz by dy at y equal to y1 into y. If I take, as I say many times I have given the example. So if this is y-axis and this is x-axis, then if how much is z? This is x-axis. At any point at any point x1, how much is the z increase in the height I am seeing right now? This is sitting on xy plane. Now If I keep y constant and I move like this at any point x, how much height I see? If I keep x constant at any point y1, what much height I see? See, one is dz by dx into x, one is dz by dy into y. If I do both, first keeping y constant and then keeping x constant, how much is the net height? That is addition of both. So z equal to dz by dx and x equal to x1 into x plus dz by dy and y equal to y1 into y. This can be equation of a surface also. If that is the case, then at x1, y1 point, what is the height? That is z equal to dz by dx, x equal to x1 into x plus dz by dy at y equal to y1 into y. At that moment, what is dz? I'm not talking about delta z. What is dz? At that moment, what is the tendency I can see to changing in z? Z equal to dz by dx into x plus dz by dy into y. What is dz? Dz equal to dz by dx into dx plus dz by dy into dy. I'll rephrase it. What is delta z? If z equal to dz by dx into x plus dz by dy into dy. What is delta z? What is dz by what is dz? What is delta z? What I'm talking about delta z. Now consider that this is the sphere, and at any moment if this is xy plane, I take any point x1 comma y1. At that point, if I go and up and it hits this point, at this point, if this point, what is the equation of this tangent surface? 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 So at this point, what is the coordinate? That is x1 comma y1 comma fx1 comma y1. If that is the case, then that height at that point or equation of the surface at that point is z equal to dz by dx at x equal to x1 into x plus dz by dy at y equal to y1, y equal to y1, y equal to y equal to y equal to y1 into y dz by dy at y equal to y1 into y. That is the equation of tangent at any point. If I know at any point, if I know what is z, then what is delta z? What is delta z? How much delta z would happen if I move delta x in x direction and delta y in y direction? If I move little bit from x1 comma y1 little bit in x direction, y direction, I have a new point that is x1 plus delta x, y1 plus delta y. If I move like this, then how much z is moved? Delta z. Then delta z equal to dz by dx into delta x plus dz by dy into delta y. Okay, it may not be very perfect. It is called single order approximation for the Taylor series. Delta s, but delta z will be bigger. This is first dimension. Plus d2 z d2 d2x d2z by dx square into x square by 1 of factorial by 1 by factorial 2 plus d2z. Okay, I'm not talking about it. I am talking, this is delta z. So if I take first order derivative only, but if I see the algebraic calculus if I see, I mean primitive calculus, at any point z is perfect. At any point z, what I see is dz by dx into x plus dz by dy into y. That is perfect. At that point, what is the tendency to change in z? If tendency to change in x is dx, tendency to change in y is dy, how much is the tendency to change in z? Dz equal to dz by dx into dx plus dz by dy into dy. If I place in terms of delta z, the delta z equal to dz by dx into delta x plus dz by dy into delta y. This is what we want, right? When we are going to calculate the directional derivative, when we are calculating directional derivative along a axis, what formula we deduce? This is xz plane, this is yz plane, this is uz plane. In uz plane, if this is the if in uz plane, if this is any point u1, this is the height. At any point u1 plus delta u, this is the height. What is change in the height? That is delta z. Delta z by delta u. This is what we are trying to find. Delta z by delta u. If that is the case, then delta z equal to dz by dx into delta x plus dz by dy into delta y, that is delta z by delta u. Okay, so dz by dx, derivative of z along x-axis into delta x plus derivative of z along y-axis into delta into delta y. What is delta x? Delta x is, if I say from here to here is delta u, from here to here delta u has x component and delta u has y component. Delta u has x component, delta u has y component. Its x component is delta x and y component is delta y. If you remember the dz by dx, the initial formula we derived is at any point x comma x1 comma y1 is fx1 plus delta u along x-axis, comma y1 plus delta u along y-axis, means its component, minus fx1 y1 by delta u. So same thing we are getting here also. dz by dx calculated at x equal to x1 into delta x, means delta u along x-axis, plus dz by dy calculated y equal to y1. We are trying to calculate directional derivative along the axis u at any point x1, y1. So dz by dy at y equal to y1 into delta y, that is delta u along the y-axis. If this is delta u, this big is delta u, the delta u will have x component, that is delta u cos theta. Delta u along y-axis, delta u sin theta. If this theta is 0, then full delta u is delta x. If theta is 90 degree, full delta u is delta y, then delta x is 0. Okay. Now, if that is the case, then dz by dx into delta ux plus dz by dy into delta uy by delta u. That is nothing but dz by dx into delta ux by delta u plus dz by dy at point x1 and y1. Delta ux by delta u. If that is the case, then what is delta ux? Delta z by delta x into delta ux by delta u plus delta z by delta y dz by dy into delta uy by delta u, dz by dx at x equal to x1 into delta ux by delta u plus dz by dy at y equal to y1 into delta uy by delta u. This is not look like a dot product of two vectors. One vector is dz by dx I plus dz by dy j dot, and then ux by delta ux by delta ui plus delta uy by delta uj. Same thing, right? Now dz by dxi plus dz by dyj is the partial derivative of z along x-axis and y-axis. dz by dxi plus dz by dyj. First calculate dz by dx. This is the gradient vector. This is also called gradient vector. Gradient vector of any shape. If this is a shape, then gradient vector of this shape will be perpendicular to it. So it will be like this. If I have a vector, the gradient of this vector will be perpendicular. What we are taking? If I am taking algebraic equation, then gradient vector will be perpendicular to it. It will be like this. If I take a vector form, then gradient of this vector, not gradient vector, will be perpendicular to the vector. So we are taking algebraic equation. So dz by dx is partial derivative along x-axis. dz by dxi plus dz by dyj. This is the gradient vector. Dot product with delta ux by delta ui plus delta uy by delta uj. Delta ux by delta u. Delta ux by delta u. This is nothing but any vector u whose x component divided by delta u is nothing but, or I can say delta uxi plus delta uxj divided by delta u. This is nothing but the unit vector. The unit vector along u vector means u vector. If I, this is a vector, right? This is a straight line. If I take any part here, this part will be same direction as the vector. If I take any part delta u length, and this has delta ux part and this has delta uy part. This is same as if I take u vector, then delta ux part, I mean ux part, uy part. But delta ux by delta ui plus delta uy by delta uj signifies this is a simply unit vector along u direction. So the directional derivative of any 3D shape fxy at any point x1 y1 along a direction vector along a vector u is its gradient vector dot the unit vector along the u. So dz by dxi, dz by dyj dot product and unit vector along u, that is ux, delta ux or ux by magnitude of ui plus uy divided by magnitude of uy divided by magnitude of uj. Okay, so we will do some exercise on this, then we will proceed through our innovative approach in directional derivative. Mind blowing. So this is the solution. This is available in any of the book. So now we will see our approach. Please do support us. +91 is the India country code 9483160610. That is the telephone number 9483160610. +91 is the India country code.